Okay, so here we're given a machine that produces metal bolts, and the length of the bolts are normally distributed with a mean of 19.8 and a standard deviation of 0.3. If a bolt is selected at random, find the probability of a length between these two values. So obviously the first thing I'm going to do is I'm going to convert them into z-scores. So our first z-score is of 19.7 and our second z-score is of 20. And we often just put a subscript in there so we know which is which, even though it should be obvious because the first number in the actual equation will be the raw score. Now, so we want to go between these two scores. So minus 3.33 will be somewhere here, and 0.67 will be somewhere here. So we want to find out what's the probability that the bolt will have a length between these two values. Okay, so we set up our probability. So we want a probability of a z-score which is between these two values. Okay, now remember what we do with this. That means we want the higher z-score, we want to the left of the higher one minus the left of the lower one. Okay, now we have a problem here because we have a negative z-score which we can't do, but to the left of a negative is the same as actually 1 minus the positive z-score. So 0.67 minus 1 minus 0.33. So we look these up in our tables book and we get 0.7486 minus 1 minus 0.6293, and that will give us a total of 0.3379 or 33.79%. Okay, so just remember when you're doing these, okay, like I said, when it's between two z-scores, it's always the highest z-score minus the lowest z-score. Now we can't do to the left of a minus 1 because of our tables book doesn't take care of minuses, but for mirror images we know that it's 1 minus the positive one. Okay, so that's all. I went straight from the left of a negative is 1 minus left of the positive.